Okay. 2.5, here's what we're going to do. 2 days on 2.5. That brings us up to Thursday. Thursday, I thought we'd slow down and just back it up to 2.1 or 2.2. 2.2 to 2.5, like a review worksheet, just to see if you're getting this stuff. Okay. And then after that, guys, I have 2 more lessons. I think Friday, next Monday, next Tuesday. We're done with chapter 2. By Friday next week, we got to be on top of our game. We got to bring our A game and score well, because that's how you start the second quarter, with a test. That's big. That's big. Okay? All right, here we go. This is 2.5. There's 2 little theorems they throw at you right off the bat. Okay, right off the bat. One is called the fundamental theorem of algebra. It says if f is a polynomial function of degree n greater than 0, then it has at least 1 0 in the complex number system. All right. What does it mean? If you have a function of degree n greater than 0, so anything greater than 0, like, what degree am I in right now, guys? Third degree. I'm in a third degree polynomial, okay? That's what that means. Then it has at least 1 0 in the complex number system. Now the complex number system is made up of real numbers, right? And imaginary. Okay, so let's not make this hard. Let's just try to make it easy. At least 1 0. Well, let's just say the 0 happens to be, let's make it easy, 5. Okay? Now keep reading. It says, this is the next thing it says, the linear factorization of f of x. If your function f is a polynomial function of degree n greater than 0, let's put 3. Let's do this one. Third degree. Because that's what I have up here, third degree. Okay? Then f, your function has precisely how many linear factors? 3. Because I said 3, didn't I? Okay? All right, in the complex number system. Okay, so guys, if this is your 0, and you have a third degree polynomial, then you have how many linear factors? Precisely what? 3 linear factors. Oh, okay. So if I factor it, I'm supposed to get, if that's a 0, what factor does 5 come from? Okay. Good. So, but they said 3. They said there's 3 factors, linear factors. Well, if I told you this is the only 0 in your polynomial, then that's a factor. What's the other one? Same. Yeah, it's x minus 5, x minus 5, x minus 5. Now, of course, you're not going to write it like that. You're going to write what? Cubed, okay. Okay, so really all I'm trying to get across to you is, if you have a polynomial of any degree bigger than 0, you have at least 1 complex 0. I put 5 down, which creates how many factors? Whatever the degree is. If it's degree 3, you have 3 factors. You have to find them. Okay, well, there it is. In this case, there it is. But every case is different, okay? Okay, now that we got through the words, let's keep going. Here's the next thing we talk about. The rational zeros test. You might remember this, you might not. Period 4, they looked like they were like, oh, I don't remember any of this stuff. And I thought, wow, we did a lot of this last year. Okay, so what is this test? If the polynomial function f of x has integer coefficients, well, now integers are like 2x to the third, minus 4x squared, minus 10x, plus 7. These are all integer coefficients. 2, 4, 10, 7 integers. If you have that, then every rational 0 of your function f has the form what? P over Q. Okay. These are your zeros, P over Q, where P is a factor of the constant term, where Q is a factor of the leading coefficient. And you have to put all this on paper and then tell me the possible what? Rational zeros. What's rational mean? Rational means fractions. So really this test is only for your fractional zeros. Like, is 7 a fraction?
Yes.
7 over 1. 2/3 is a fraction? Yeah. That's all I'm testing for. What are my possible fractional zeros? They don't say fractional, they say what? Rational. That's what that means, okay? Next up, here we go. Take that function right there and give me the possible rational zeros. The only way to do it is to write your factors of your constant over the factors of your leading coefficient and then tell me all the possibilities. So, what is it going to be? P's over what?
Q's.
Q's. Okay, here we go. P's are what, Paul?
These are possible rational zeros. Wait. No, they're the constant terms.
Nope. Close,
Factors
you're
of
close.
constant terms.
Factors of the constant term. Which one's the constant term?
Negative 6.
Paul, stay with me. Which one's the constant term?
The 3, the
Negative 6.
5. Wait, it's a -6.
It's the number without x, right?
Yeah.
Okay, here we go, guys. Give me the factors of -6. Say it. Anybody.
3 and 2.
Plus or minus 2.
Plus or minus 1.
1, 3, 6. Got it. Okay, good thing you guys said plus or minus because negative numbers do go into constants. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Over the q's, and the q's are
3 and 1.
factors of what?
1 and 3.
Factors of the what?
Leading.
Leading coefficient. Where's the leading coefficient?
3.
It's in front of the highest power of x. It's right here. That's the leading coefficient, 3. So factors are 3 and 1. There you go. That's not the answer. The answer is going to be what are the possible zeros? Possible? Well, you could have 1 over 1, 2 over 1, 3 over 1, 6 over 1, which would give you what? Basically what I just read to you. Okay? But there's more. What are the other ones?
1/3, 2/3.
Okay, 1/3, yes. Then what? 2/3, yes. How about this one? 3 over 3. That's just 1, don't do it. 6 over 3. 2, don't do it, you already did it. Good? So how many possible zeros are there? 2, 4, 6, 8, 10, 12. There are 12 possible rational zeros. Now, how many zeros are there to this problem? How'd you know there's 4? Because it's a what degree polynomial? 4th degree. 4th degree means how many zeros? 4 zeros. Is it for sure they're all in here?
Yes.
No, because these are rational zeros. Could they be imaginary? Yes. Could they? If it's not rational? What do we call it?
Irrational.
Irrational. Now, what's irrational? Can't be put in fractional form. Give me something. Square root of 2. Square root of 3. Square root of 5. How about pi? Pi is a decimal that goes on forever and never what? Never ends. Okay.
And it doesn't never repeat.
Never repeats. If it doesn't repeat, you can't write it as a fraction. If it repeats, you can write it as a fraction. What's 0.33333333?
1/3.
You can write it as a fraction. So 0.3 repeating is a fraction. Anything that repeats is rational. Anything that doesn't repeat is, say it.
Irrational.
That was really high. How'd you do that? That was such a high Paul voice. Say that again.
Almost like
Say that again.
irrational.
It would have been better if Gracie said it.
Well,
Okay, next. Oh, by the way, we have the answer. Did you see it? There's the answer. Your possible zeros are right here, guys. On the test, I will have one question that just says, give me the possible zeros. I'm not going to say find them. I'm just going to say, give it to me.
You missed 2/3 in your box.
I missed 2/3 in my box. He's right. Okay, there it is. Okay. let's go do it now. Here we go. What are the possible zeros of that polynomial? You guys get that on paper. I'm going to space this out a little better so we have more room. Just get me the possible zeros. Okay, here we go. P's and Q's. P's are factors of the constant. Which one's the constant, Mason?
2.
2. What are my possibilities? Okay. Okay, got it. Thank you. What are Q's, Carly?
Plus or minus 1.
Okay, but Q stands for what?
It's the leading coefficient.
Leading coefficient, which is right here, guys. It's 1. And boy, oh boy, you should smile when it's 1, because there's not much to do. She already said it. It's plus or minus 1. So what are my possible answers? Possible zeros?
Plus or minus 1 and 2.
Okay. 1 and negative 1, 2 and negative 2. Got it. Okay. That's it. Test number 2. Test these zeros that you came up with using synthetic division until you find one that actually works. And you might be unlucky and you might get it on the last try. But we're going to do this. As a group, let's do this.
I got it.
You three, we'll try 1. Try 1. You back row, try negative 1. You guys try 2, 2, 2. You guys try negative 2. Okay. Try negative 2. You guys. As a group, we're kind of cheating here, because this is not how you get to do your homework. You don't get to ask people. All right? Did 1 work?
Yeah.
You go no, and you say yes.
Wait, 1.
It works? Okay. Hey guys, 1 works, I guess. How about negative 1, guys?
Yes.
Yes, how about 2s?
Uh-huh.
2s work?
Yeah.
Did negative 2 work? No. Okay, so here's the deal. 1s work, negative 1s work, 2 work. I got all the answers, I already know it. But I gotta show the work. Okay, so I'll stick with this group first. So they said 1 works. Okay, now watch this. You put a 0 here, you put 1 down. Multiply 1, add down negative 1. Multiply negative 1, add down negative 2. Multiply negative 2. You're right, 0. 1 is a 0. So I'll go like this. I already know a 0. What's one of my zeros? 1. So I test, and here's the deal. You don't have to keep testing. Once you get it down to 3 numbers, okay, 3 numbers, then it says use that 0 right there to write the factorization of f of x. So finish it, factor it. You guys should know this. This 0 actually came from a factor. What's the factor? Yeah. Okay. If you actually divided by x minus 1, and you got a remainder of 0, that means what's left is also a factor. Okay, this is the remainder of 0, so this is the last factor. What is it? X
squared minus x minus 2.
Perfect. And once you get to a quadratic factor, you don't have to sit there and do synthetic division. Just try to get the zeros out of it.
X minus 2x.
How? How about doing this? Factor. And you said what?
X minus 2x plus 1.
Okay. Whoa, whoa, whoa. Try that again. X minus 2, x plus 1. Okay. With an x minus 1 in front, right? Okay. Would you agree that these 2 factors multiply to give you this up here?
Yeah.
Yes, everybody? Okay, guys, right there, you can pull out your zeros. They are 1. They are what? 2 and
Negative 1.
okay. Now we knew that because this group said 1 works, The back row said -1 works, and you three said 2 works. And you guys told me -2 doesn't work. So I kind of knew the answers going into it, but that's not how it works. You always find one, and once you get it down to 3 numbers, it's a quadratic factor. Go factor. Now I do have a question. What if this isn't factorable? Quadratic formula. Exactly. Okay? Now, I gotta ask you this. This group, I worked with you guys. I worked with your number. What if I would have picked -1? The only difference would be these 3 numbers would be different, but it would have factored, and I would have got these 2 zeros. And if I would have worked with your guys' 2, these 3 numbers would have been different. I would have factored it, and I would have got these 2 answers. Okay? Will, stop. Get off your phone. Chris, I just can't look at that anymore. Okay? All right. Good? Okay. Here's the deal. You got to keep this straight in your head. There are things called rational zeros, right? And then there's real and complex zeros. When they say rational to you, find the rational zeros, what they're saying is, do what? They're telling you do p's over q's. Go find the zeros that are fractions. Okay, so that's how you start a problem. Okay, but then they say, well, what if they said, go find all the real zeros, or maybe they say, go find all the zeros, complex zeros. Well, real zeros, these are real, by the way. Rational is real, but irrational also is real, so you could get answers like this, you could get answers like this. The thing about this, what I'm writing to you right now is, this doesn't do what? Doesn't repeat, and if it doesn't repeat, it's irrational, but it's still real. And now complex zeros look like what?
0 plus 3i.
Okay, 3i. 7 plus 5i. That's what that is, okay? Now, how exactly are you going to find these? Okay, there's 2 ways to do it. Oh, by the way, how are you going to find the zeros using your p's over q's? You-
Constant.
Yeah, okay, constants, leading coefficient, but you're going to do what after you do that? You're going to use synthetic division. Okay. Okay, synthetic division will get your p's over q's. You just put numbers in, you see when you get 0. But if you're going to look for real zeros and complex zeros, they're going to be found by factoring, kind of like what I did on the previous problem. And if I can't factor it and pull out the zeros, I'll do what?
Quadratic.
Quadratic what?
Girlfriend.
Okay.
Girlfriend.
Your girlfriend. I don't know what I said there, but whatever. Okay, so what is this? You better know it.
X is equal to negative b plus minus
Over what now?
4ac.
4 AC.
over 2 times a.
Okay. Good. By the way, for you to use the quadrant has to look like this: ax squared plus bx plus c equals what? 0. Exactly. If it does not equal 0, then you have to move the number over here with c to make it equal 0 before you start. Okay? Good? That slide was nothing more than just to kind of organize your thoughts. Okay, here we go. Without the use of a calculator, because I will let you use calculators, but not now, find all the zeros of this function.
Using what?
Well, I'd start with my p's over q's. I'd start there. Always, this is your startup. Always go here first. Give me a head start. First step's done. I know my possibilities for fractional zeros, rational zeros. 1, -1, 2, negatives. Now I'm gonna kind of cheat. I'm gonna ask you guys. Give me a 0.
2.
2, okay, let's do 2. Okay, so I do 2. Here we go. 1, -1. Uh-oh, I lost it. 1, -1, say it please.
Oh.
Okay,
Two.
positive 2, okay. And you said 2 works, right?
Yeah.
Okay, 0 here, 1,
Oh.
2 here. Whoops, 1, 2 here, -1, -2, 0. Okay, I agree. 2 is a 0. Okay, so we want to find all the zeros, whether they're complex, real, rational, whatever. We gotta find the rest. Okay, so I already know one of them. One of them is 2. This one, 1, 1, -1, would mean this is the other factor, right? Okay, and I know this one, I know 2 creates this factor, right? Okay, can I not? I can't factor, he says. Is he right?
Yeah.
Alright.
Okay, let me try it really quick. There's not many choices for -1. -1 times +1. Does this times this equal this? No? Because this times this is -1. Perfect. But this plus this is 0, and I have a 1 here. It's not working, guys. It's not factorable. What do you do? Formula, go. Go get it. Just looking, see what you got. Looks good. See, 1 or 2 people have it. No, that's good. That's good. That's it. Get it? Yes, no?
I do.
Where is it? Oh, way up here. No, something's wrong. Something's wrong.
No, it's perfect.
Say that number.
Yes.
Inside it. What is it?
I got.
Is that 5?
I
Oh,
got
that was
-1.
You're close. So we'll make it twice.
You're good. That's it.
What do wrong?
Okay, here we go. Here we go.
Oh, you
So, opposite of 1. -1. Square what?
1.
The 1. Take away 4 times 1 times.
-1.
Yep. Okay. 2 times what? 1. On the bottom is 2. On the top you have this plus or minus this mess. 1 times 1?
1.
This times this times this. 4? Which is what? 5. The square root of 5. Okay? Good? Now, here's the deal. How many zeros do you see up here?
2.
There are 2. -1 plus this over 2. -1 minus this over 2, right? Plus you got that one over there. So really, there's a 0. X equals 2. And here's 2 more zeros. Is there supposed to be 3 here?
Yeah.
Why?
Because it's to the third.
It's x to the 3rd. Okay? Good?
I have a question.
Yeah.
So isn't that -4? It multiplies times -1.
Okay. First of all, don't even look at the signs. 4 times 1 is 4. 4 times 1 is 4. Negative times negative has to be positive 4. Right?
Oh yeah.
You know what I'm saying?
Yeah.
Okay.
Do we have to like write those out as numbers?
Write those out.
I mean,
No, you have, okay,
Those.
you have, I understand there's two answers here. The first answer is -1 plus square root of 5 over 2. Second answer is -1 minus square root of 5 over 2. Perfect, I got it. Okay, good. I'm moving on. Okay, let's do it again. This time, graph this function that you see on your calculator. Why? To help you find one rational zero. Because some of them are non-rational, some of them are real or imaginary. Okay?
Hockey Kyle.
Oh, you like
Okay, guys, but before you graph it, you should do your P's over Q's right now. Get your P's over Q's. Just see what your possibilities are. Okay? Agree?
yeah.
Okay. Now, you have 6 choices, but because you have 6 choices, sometimes you'll have 8, sometimes you'll have 12. Your calculator can really narrow this down so you know what to start with. So you graphed it, correct? You got a picture, right? And show me your picture. Okay, this is what Maddie has. Maddie has this. She has it going kind of like here. Here. I see it here. And then right about there. Okay, so this is what Maddie has on hers. Now you kind of know that out of the 3 zeros, one of them is a rational number. Which one's rational? The one for sure you can tell is rational. 2, right here. Hey guys, you don't know what that is. That could be 1.3789, whatever. You don't know. You don't know what that is, but you know that's 2. So what I would do now, using my calculator, is start with which one? 2. Why wouldn't you? You know it's a 0. So the calculator is kind of doing the cheating part. It's like saying 2. Go with 2. And we know it's a 0, right? So we can put a 0 in there right now if we want. Hey, look, it worked. It worked. And I knew it was going to work because the calculator is telling me it's a 0. Okay? All right. Use synthetic division. I just did it. 2 factor g of x up here. Then use the quadratic formula to find the remaining zeros. Okay? So right now, I have this. This is one of the factors times what's left. X squared minus 2. Okay? To get the other factor, or other zeros, it says use the what? Formula to get the other 2 zeros. Go. What's your b value?
0.
Square the b, take away 4 times a times c. A is 1, c is -2. You're getting what? plus or minus square root of
8.
8, okay? But 8 is really 4 times 2, which means you'd have plus or minus 2 square root of 2 over 2
Plus minus square.
plus or minus square root of 2. Because those cancel out. So your other zeros are right here. Here's 1 0, 2. Here's another couple, square root of 2 and negative square root of 2. All right. Is there anybody out there that's going to say, wait a minute, you didn't have to do all that work, Mr. Painter?
Kyle didn't have to do all that work.
Why? You gotta follow that up with what?
No.
You're just looking in the back of the book.
Look in the calculator for the 0.
I couldn't back.
Just type in the 0 thing on the calculator.
Second.
Okay, tell
Yeah,
watch.
second.
You guys, you're not getting it. And you guys,
0.
100. You guys, this is so easy. You guys, when you looked at this, I was hoping you would look and say, why would I have to use the formula when I can just do this? When is x squared minus 2 0? Could I have just solved it? X squared equals what? 2. Square root of both sides.
Plus or minus square root of 2.
I'm getting the-
When can you do that?
When
When there's no b value.
When there's no b term. Bx term. Bx term is missing. Go do this. Don't use the quadratic formula. I mean, you can, and you see it works. It's just more work. Don't do it. It was a trick. You were supposed to say, slam on the brakes. Don't do that. Solve it, right? But if you have a middle term, an x term, you have to do what? You have to do the formula unless you can factor, but we couldn't factor. Okay, we tried.
So we're done now.
We're done. Yeah, we got the zeros. They're right here. Here, here. Or here, here. Okay? Go. I didn't write the directions, but just find the what? Zeros. Go find them. There's your directions. Right there. 5 minutes, we can get this done. Whenever the leading coefficient is 1, aren't your possibilities really just the
P's.
the numerator?
Yeah.
Yeah, it's just the p's, yeah, or the numerator. Okay, so this, you have 8 choices. Which one is it? Now you could graph it with your calculator and kind of guess a couple of them.
2
2 works.
2 words.
Did you graph it? Is that what you did?
No,
No? Okay. All right, so here we go. If he says 2 works, let's start there. It's 1 followed by what?
0,
Then,
-2,
then,
0.
and negative 8. Okay. We're hoping he's right. 0. Bring down the 1. Multiply 2, bring down 2, multiply 4, bring down 2, multiply 4, bring down 4, multiply 8. We got it. It's 2. 2 is a what? 2 is a 0. Okay. But wait a minute. This one's going to have how many zeros?
4.
Okay. 4 zeros. Now, some of them could be rational, and some of them could be imaginary. Some of them could be just irrational. Keep going. Try it again. You want to get it down to 3 numbers, not 4 numbers. 3 numbers would be quadratic. When you tried 2, you got it to work. What? -2, says Grace. Let's see if she's right. 1 there, and this is -2. Add, multiply, add, multiply. Answer. Hey, it works. You got another one right there. Look what you have left. Guys, that's 3 numbers.
No b value.
That's a quadratic, right? Okay, what's it going to be?
X squared plus 2.
X squared plus 2. You do know, I think you know, I hope you know, it's x minus 2, x plus 2 times x squared plus 2. But you already know the zeros in the first two.
Negative.
So plus minus square root of 2.
Okay, this one, what are you gonna do?
Minus square root of
X squared plus 2 equals what?
2. 0.
X squared equals what?
2.
Plus
Negative
or
two.
minus square root of 2.
Square root of both sides.
Plus or minus square root of negative 2.
Plus or minus I
Square root of 2.
square root of 2. Two of them were real, two of them were imaginary. Okay? You okay?
Yes.
It's kind of a lot of work. Okay? P's over Q's. That's today's lesson.
No homework tonight.
What?
There's no homework tonight.
No homework? Well, it goes up to 39, just so you know.
Oh, it is.
39.